When we hear about plastic in the ocean, we picture bottles, bags, fishing nets, but the overwhelming majority of plastic objects in the sea aren't visible at all. They're microplastics. Microplastics are defined as plastic particles smaller than 5 millimeters in size. But that's just the upper limit. At the lower end, some fragments are only a few micrometers wide, and even nanoplastics exist. Particles made of just a few dozen to a few hundred monomer units. At that scale, they no longer behave like debris. They behave like suspended chemical pollutants. And here's the paradox. In terms of mass, microplastics represent only 10 to 20% of the total plastic in the oceans. But in terms of particle count, they make up 80 to 90% of it. In other words, nearly all the plastic objects in the sea are microplastics. We just don't see them. Once released into the water, these particles don't stay still. They move, influenced by currents, temperature gradients, salinity, and their own physical properties. Density, shape, surface chemistry, charge. Some plastics are buoyant and float for long periods. Others have nearly the same density as seawater and stay suspended in the water column, drifting for years. Some are denser than water and sink to the bottom quickly. And even plastics that start out floating don't always stay that way. Over time, they get colonized by microbes, algae, tiny invertebrates, a process called biofouling. As their surface gets covered, their density increases. Eventually, they lose buoyancy and begin to sink. This process changes everything. Current estimates suggest that more than 50% of microplastics end up on the seafloor. Around 25 to 35% remain suspended in the water column, and only 5 to 10% stay at the surface where we can actually detect them. In other words, the plastic problem is three-dimensional, and most of it is literally out of reach. That makes any large-scale mechanical cleanup operation extremely difficult, not just because these particles are tiny, but because they're everywhere, from the surface to the depths, from coastal zones to the middle of the ocean. So if we, as humans, can't realistically collect or filter these particles ourselves, then maybe we need to ask another question. Could something else do it for us? Over the past decades, scientists have discovered several life forms that can interact with plastic at the molecular level. They don't just break it into smaller pieces, they start to depolymerize it, to transform it back into simpler, more digestible molecules. But who are these organisms? What plastic can they actually consume? And what exactly are they doing to it? That's what we'll explore in the next episode.